Hey everybody, it's the Deephaven community team back with another demo. It's August week 3, and we have Devin who's going to show us something. All right, here we go. Devin, take it away.
Hey, in the past couple of weeks, I've shared some demos about protobuf parsing, and I've got another demo kind of demonstrating the same thing here, but this time it is a bit more end-to-end, and it's specifically demonstrating how uh, the protobuf parsing logic deals with schema changes. So I'm going to start off with an empty schema registry here and no topics. And what I'm going to do is I'm going to pretend like we're a web server. We have a web server that is writing down an access log. This isn't a very far-fetched idea. I kind of stole the idea from something that Envoy actually does. They have a very long and complicated protobuf to write out access logs, but let's just pretend we've got a little bit a simpler one here. So an access log is just a log that gets written down when a web server receives and returns response. So, get, put, the address, the IPv4 address, the path requested, and the response. And what I'm going to be doing is I'm basically just going to be mocking some of this stuff up right here. I just started a fake web server that's getting some fake requests. We'll go ahead and refresh so you can see we have an access log topic here. We've got a schema registry. This schema has been registered here. And what we'll go ahead and do is we'll go ahead and run the Deephaven and Kafka consume with the protobuf spec. So this is the new thing. We give it the topic, we give it the schema name, and we give it the schema version, and then the message that we want to parse. So we'll go ahead and do is run this, and we'll get a couple of aggregations going here. So you can see as we've got access log here ticking about once a second with the data that I described. Here's the metadata for that table parsed out of the protobuf descriptor. And here's some simple protobuf stats. One of the nice things about protobufs is that it can handle schema changes though. So I'm going to go ahead and restart the schema with something new. 1 second, let me do this. And I'm going to restart it. And even though we've subscribed to V1 of the schema here, it's still ticking, even though I just changed it to a new schema. So if we go ahead and refresh this, this is the schema I just changed it to. I went ahead and added a user agent. I added content to it, and I added a port to the address. If we go ahead here and refresh the schema from the schema service, you'll see that this is version 2, and the new fields are here. But our existing query is continuing to tick. It doesn't know about those new fields, but all the other tables are still ticking correctly as we originally queried them. So let's say, okay, now our producer has changed and we want to update our consumer, so we can go ahead and do that. The code's going to look very similar, except I'm just going to pass in schema version 2 here. And now we've got some content sizes, we've got some ports, and we can do some statistics on those ports. So if we go ahead and run it with version 2, you'll notice we get a new set of tables here. I will just drag these down below so we can compare them. So here we go. Access log is ticking on both. But in this version, we've got a user agent now, as you can see, and we've got optional content being filled in, and a function column that we've created from one of them. And then the stats on this one are still working, and you'll notice that we've got some new statistics here that we couldn't do with the original V1 because these data points weren't available. So let's go ahead and just do one more update to show you a different type of update that might happen. Stopping my server and rerunning it real quick. So now the schema has changed slightly, and now this is not really a schema you'd see in the access log, but let's say we've changed the content. Field 8 used to be content, but let's say we can differentiate between types of content. Let's say one's a home address and one's a job, and there's only going to be one of them. So let's say we made that change. Again, our original queries are still ticking away, as happy as ever, not knowing about these new fields. But if we go ahead and update our new query, we need to take in home address and the new job field if we want to calculate the content size, and then we'll do those with the V3 again. So let's go check out the access log here, access log V3. So V3 now has a difference between home address and job. And these stats are being treated right here. So anyways, the idea is that the Deephaven protobuf consumer will handle the schema changes behind the scenes, just as protobuf was designed to do, and your tables will continue ticking as you originally designed them to, even if stuff changes in the back end. So as you'll notice in our V2, we didn't have some of the content because it doesn't know about it, um, but V3 does. Anyways, that is the protobuf Kafka with schema changes demo.
Neato. All right. We'll see you again next week. Cheers, everybody.